we had this interesting result that the current through the resistor is the EMF divided by I. So what we would have then is this is the motional EMF times the motional EMF, divided by the resistance, or the EMF, the motional EMF squared divided by the resistance. But we would notice this is just the power that's dissipated through the resistor. So now we see there is this perfect balance of this mechanical energy that we are putting into the system. So that's mechanical energy in. And here we have the electrical energy coming out. And that all can also be seen directly in this equation, because on the right-hand side, this is electrical power. And on the left-hand side, we have, again, the mechanical power in perfect balance. So now we can understand where all this electrical energy comes from when we move the wire through the field. There are forces that are required to make that wire move so that we can actually generate the electrical power that's coming out. And these align perfectly, and in fact the signs on them have all worked out perfectly as well. So I think we can give this a good happy professor symbol. We always like to do this when we see that that energy is actually conserved. Now this leads us then to other considerations and other rules of thumb that help us determine the ways currents flow and the signs on various forces when we are dealing with motional EMFs, and also more broadly when we deal with Faraday's law.